So let's talk about how FDD can really transform how you do maintenance, or at least can be a help. Don't laugh at this slide. It's supposed to make you laugh. So I pulled up what it takes to maintain a typical building. This is recommendations by an ASHRAE standard for what PMs to perform and how frequently. If we were in person, I would make you raise your hands of how many of you truly do all of these PMs at this frequency. But I can say from my experience, talking to people, it's not many. So the gold standard of, doing a VAV box PM quarterly, I don't know that happens very often. But this number is, you'd be doing PMs, 955 PM checklists per year for just this one building that is pretty small compared to a lot of campus buildings. So the foundation here is that with FDD, you can supplement some of those PMs that maybe you're not getting done, or you can make decisions about how much of your PM to perform and when to perform them. Because, if your FDD system can perform checks on each of these pieces of equipment that sometimes would supplement some of those checklist items on your PM, it would potentially take the place of that. On top of that, by running FDD against systems, you may not need to PM certain pieces of equipment. You might be able to just let FDD tell you when they're close to needing repair. So again, this example is with Clockworks analytics. It's going to be different for any FDD provider that you have, the number of those analytics and what they're able to do. So again, important questions to ask when you're talking to your providers, when you're interviewing them. So we're going to look at this in kind of a calendar view. I thought this is so impactful. So here's a week for a technician doing PMs in a dream scenario. They show up, they do that chiller PM on Monday, they get the AHU in the morning on Tuesday, they do some semi-annuals on their VAV boxes, they got the boiler or cooling tower, no problems. No one calls them, nothing's broken. They just go about their day, they get that PM done, they check those boxes, they say, ASHRAE, I'm doing exactly what you want, but this is reality. I think the studies are showing that greater than 55% of work orders in buildings are reactive maintenance. I think in facilities on campuses, it's probably higher in a lot of places. But things get upended. That quarterly chiller PM that you wanted to do got upended by this BS alarm with your air handler. You don't get any of your VAV boxes done on Tuesday because you're getting comfort calls. Everything gets pushed. And then you go back and you look at the end of your week and you've done 55% of your PM that you were supposed to initially do, and then you're always working from behind. So let's look at one example where you might be able to use FDD to supplement some of your PM work and to help you get your feet under you with maintaining your facilities. Let's just do highest impact work. So these blue squares would be where you'd be doing something that's FDD related. So maybe on Monday morning, you come in and you look at your FDD software and you assign some work orders. So you're planning your FDD response work. You're not stopping what you're doing and going and responding to a fault. You're planning it and you're scheduling it. You're saying Tuesday and Wednesday, I'm going to hit these 2 items and I'm going to get those done this week. And by doing that, when you hit that AHU that had a high KW per CFM that was maybe telling you your alarm, your fan was probably not operating optimally, you upended that BAS alarm for your fan failure. And maybe by hitting that fault that came through to recharge your chiller 1 refrigerant, you're getting ahead of that alarm that's coming out saying you have a high discharge air temp on your chiller. So it's using that highest impact work to prevent those alarms from happening. You're planning out the work, you know what you need, you have the equipment you have, everybody's ready. It's a much less expensive way to do work. And then the second level, once you kind of get your feet under you, you understand how you're using FDD, you understand the tool, now we can do what we call enhanced preventive maintenance. That's where anything that's a blue box is as a result of FDD. So that's where you can say, maybe I don't need to do any PMs on my VAVs, I'm strictly going to respond to high impact faults, and I'm going to prevent those PM tasks or maybe make them very small. Maybe I can cut some of my chiller PMs in half because I can do a lot of it looking at the analytics, same with your air handlers. So once you understand how your FDD program can supplement your preventive maintenance program, you are in the sweet spot of quarterbacking rather than firefighting. So instead of dropping everything, not getting anything done, you are in a more planned, routine, proactive, preventive mode where, yeah, I know I'm not going to PM all my VAV boxes quarterly, but instead I'm going to choose to do FDD on those VAV boxes. I'm not going to do my air handlers quarterly. I'm going to have FDD running on those air handlers, and then I'm going to do them semi-annually when I do a season change. And maybe I only need to do half my PM tasks because I know that FDD is running and I can trust that what they're giving me is going to find any of these other issues. So it's really being smart about how to supplement your maintenance program to get in a position where you're not constantly firefighting and reacting. You're being proactive and preventive. And by having that last D, that diagnostic, that information that's coming to you, the timeline to troubleshoot problems and make corrections is much shorter. So you're also saving a lot of that desk time. So once you're into quarterbacking, you can do some of these other things that are also insightful from an FDD program. There's lots of them. I'm going to give you 2 or 3 examples. This one is really at the front of our minds because of COVID. Where ventilation quality is becoming very, very important to our occupants on campus. And by having a system that pulls in all of this data, knows what type of systems you have, knows where your dampers are supposed to be or not supposed to be, you're able to get these kind of insights where we know I have 400 air handlers that I'm looking at every day. It's impossible to check the outside air dampers on all of them by sight. This will tell me that over the last 7 days, I had 450 instances where my fresh air dampers were below minimum. I had 100 air handlers with IAQ issues out of 400. And so it really allows you to kind of tell the story of here's where we stand from a ventilation standpoint with our air handlers. But another really big one is our zones. So if you have an air handler that's providing the correct amount of fresh air, but half of your zone dampers aren't working, it doesn't matter. You're not getting that air change rate. And that's an even harder one to keep an eye on. I mean, we're talking about 10,000 zones across this campus. So to be able to say, hey, look, these are all the ones where my supplier flow is lower than my set point, I should probably go take a look at those. And maybe I'll only look at the ones that are 50% off of set point or higher. And I'm going to prioritize and look at those. So it really allows you to take that information and make it actionable. And here's some real world examples of when a campus was preparing for the fall, some of the things that they found using FDD that were related to IAQ at the zone level. And none of these findings, I don't think they will be surprising to you. Stuck fire dampers, loose set screws, calibration problems, programming overrides. These are all things we see every day when we're going to respond to hot or cold calls. And also things that if the paradigm hadn't shifted with COVID, we probably would never look for unless a comfort call came in. So stuck fire dampers happen all the time. We don't have a lot of visibility into them. You know, they oftentimes will just close on a blue and they're hard to find. And so these are all very important things to take a look at. So these are just, a handful of examples of things that were found. The other thing is, yes, we talk about energy savings. We find things that are broken, like our economizer is not operating when it should be. That's a problem. But there's also opportunities that can be highlighted with FDD because they know what your systems are, they know how they operate, they know how they're supposed to operate, and they can quantify the cost. They can say things like your air handler doesn't have a reset, and if it did, you'd save $10,000 a week or a month or whatever that number is. Your heating system, your return temp is low and your hot water temp loop differential. You have a low hot water temp differential, so you're not getting great efficiency off of your boiler. Same with your cooling system and your zones. Maybe your zones are operating when your building is unoccupied and they're frequently coming on and pulling your air handler on at night. These are all things that when I was a consultant in energy management, I would go and create this list of ECMs and charge my client, you need to do these things. I see that you're running when you're unoccupied, but in this, it's real time, it's available to you at your fingertips, and it's smart. It can give that cost savings real time to you for how much you wasted the prior week, the prior day, the prior month. The other thing that it can really do is help you to improve your standards, right? So if you notice that you're getting a lot of faults for different things that are not operating per, new design, you can start to make those changes and then make it part of your standard operating procedure for your sequence of operations. And the last one I want to show you that is also very impactful is this improved construction handoff. So even the best campuses that have great turnover for new construction will still run into issues with things that either, we weren't aware of on the maintenance side that the construction made changes to, or, it's a large beast to swallow. But this is an example of a building within the first year, it was fully commissioned, issues that were found. Again, I don't think any of these will be surprising to you. Coils that were valved off, actuators that were not installed properly, sensors that were out of range. These were all things that could be handled by warranty. So not on our dime, on the contractor's dime, all within warranty, and you find them fast, which is why that's so important, because if you let this drag on until 2 or 3 years later, when you start to get familiar with the building and how it's supposed to operate, and you get that institutional knowledge, it's too late. And then you're fixing all of this stuff on your dime. But another really important thing here is this example. I mean, first of all, lots of issues, but the bracket was already bent. And it actually led to a design standard change to not allow this type of device to be used in new construction projects, because it was something that, within the first year had already worn out. I think I have a question. Yes.
Yes. Do you see Scott's question or statement? Would it be great to demonstrate? It would be great to demonstrate warranty issues as well after opening new project.
Yes. So that's exactly what these are, Scott. So these are warranty items that were identified after construction had started. It's just a sampling of them. I just grabbed it out of the tool. So yes, exactly. Great for that, but I think also great for bridging that institutional knowledge gap. So I know in my experience in higher education, when a new building comes online, especially recently, the sequences, the equipment, it's all really high tech. The sequences can be very, very complicated, multiple pages on how to make a zone comfortable. And so this does sort of help, like little training wheels to get up to speed on how everything is supposed to be operating by bringing you kind of, here's the expected mode we would see, and here's what we actually see. It helps you get more familiar with that building quicker. So those are just some examples of, when you start to use the tool, build it as part of your operating procedure, get it as part of how you do work day to day, it leads to investing in your infrastructure rather than spending to fix it. And making sure that we are truly keeping things running and humming, and then you're starting to get all that cream off the top, right? You're looking at optimization, you're looking at ways to improve our design standards, you're looking at ways to really, get even more out of the tool than just strictly finding things that are broken, right?